Hello, I'm doing section 10.1, objective 3, the back page here. So we're asked to find each of these roots. To begin with, I wrote down that 3 to the 4th is equal to 81 and 3 to the 5th is equal to 243, just so we have that information. Okay, so I'm going to start with the easier one first, and I'll get to the harder ones. Okay, the first one says the 4th root of 81. Because this is true, we know it's going to be equal to 3. Okay. This one is just like this one. The only thing that's different is the negative on the outside. So what I'm going to do is take the 4th root of 81 and then write down the opposite. So the 4th root of 81 is 3. So this would be negative 3. Okay, for this one I have the negative on the inside. You should never have a negative on the inside with the index being an even number. This is a 4. Whenever this is negative and this is even, you're always going to say it's not real. And again, the reason why is because you cannot think of a number that you can raise up to a 4th power to get a negative answer. There's no such number. If you take any number, whether it be positive or negative, if you take it to the 4th power, it would be positive. So this is not possible. Okay, let's go on to these next ones. The 5th root of 243, that relates to this right here. Since the 5th root of 2, we have the 5th root of 243, that's the same thing as 3, because 3 to the 5th is equal to 243. And then if we take a look at this one has an odd index. It is possible to find an odd root of a negative number. Okay, so if I take a look at this and I just write it a little bit differently here, negative 3 to the 5th. If I take negative 3 to the 5th, that's negative 3 5 times. So negative times a negative be positive, times a negative be negative, times a negative be positive, times a negative. The whole thing becomes negative 243. So if the index is odd, it is possible to find the answer. This answer would actually be equal to negative 3. So just kind of summarizing here, this one especially, if the index is even and you're trying to find a root of an even index where the inside is negative, that's always going to be not real. So just kind of remember that.